In this video, as part of the previous videos I loaded or uploaded into YouTube, we are going to talk about performing structural equation modeling, specifically confirmatory factor analysis using JMP. So when you are using JMP Pro, I'm using JMP Pro. You can watch this video and learn how to do that. So, however, from best practice, they are saying that, or it states that it's always advisable to do exploratory factor analysis first to know the factor structure of the tool you have, which is mostly influenced by the particular population of study. Maybe the scale was done or validated on students, then you have modified it to use it among maybe those who are in the field, maybe those who are working. So you need to do exploratory to identify your factors or components before you can go with the confirmatory factor analysis. So the first thing I'm supposed to do here, we are going to do two things before we do confirmatory factor analysis. We are going to do what we call the exploratory factor analysis using maximum likelihood and also variance rotation, orthogonal variance rotation, after which we check the reliability of the tool using Cronbach alpha. After that particular analysis, we proceed to structural equation modeling. So I have a scale here which was extracted from JASP. It's an example data set which is made up of 5 items, and the scale is a mania scale used to measure or assess mania. So, and the number of respondents in this study or the observations is 78. So I need to check the descriptives. That will be the first thing to do before you go with any factor analysis. So I'll just click on distribution, select my first item, hold shift, click the last one and click Y columns. Click OK and you have your output. So what should interest you when you are doing factor analysis is the skewness and kurtosis. So you can press and hold command or control, click here, customize summary statistics, then you have skewness kurtosis. So we can decide to uncheck these things so that we can see our output very clearly. So this is what we have. So you go through, see skewness is less than 1. Kurtosis, when you go through all these items, you realize that the skewness is less than 1. Kurtosis is also less than 1, which is a multivariate normality. It means that they are normally distributed. So it depends on the approach you are using, but you only need to cite the particular book you are using or the particular article reference. So after doing this, we need to do the exploratory factor analysis. So you just click on analyze, multivariate methods, you see factor analysis. So you click on it. So you click and drag all items into, or you populate the box Y column with all the items. Then you click OK. So our extraction, the factoring method, we are going to use maximum likelihood, even though it is recommended that you use a minimum sample size of 200, but we do not have so many items or indicators, so we can run confirmatory exploratory factor analysis using this. So, and one thing about JMP is that when you look at its output like now, you know the number of factors you are extracting. So you look up there, you see what we call the eigenvalue, and any value above 1 is a component. So if you have 2 components with eigenvalue more than 1, it means that your extraction will be 2. So you see that we only have the first component, and there are 5, and the only one with more than 1 eigenvalue is the 1. So it means our extraction is going to be 1. So if you look at the graph here, you can resize it this way. You can do it this way. So you see, so from here to here is the first factor, from here to here is the second factor, from here to here third, then the last one That's fourth. So, and with this, look at something. When you take from here to here, you realize that the extraction is more than one. I mean the eigenvalue. So we only have one extraction. So this is the line. See how it extends, and this is a line. That's one. So it's good, and you can see very clearly. So we want to do the extraction, but we don't want to use. We want to use just the common factor analysis. We don't want to use the principal component analysis or extraction method. So, and when you look at here, you realize that the number of factors is one. It means that we're extracting only one factor. So you already know what you are doing. You only need to change these to the particular rotation method you want to use. But we are going to use Varimax. So click on OK. Then we have our output. So you see that we have the TLI to be 88, RMSE to be 0.134, and we have the loading. So it means that we only have one factor here extracted. So you see we have 0.8, 79, 67, 55, and 43. And it is recommended that any item with a loading less than 4 should be deleted. So that's why you see here dim text 0.4 and below. But mostly, even if you have 0.4, you can consider it in your model to see how well they perform. So we can decide to ignore this without deleting this item to see. So let's note the item. The item is item 3. So let's go to the reliability to see if we have above 0.7. If it is not, we have to delete the item. So we just have to click on Analyze, Multivariate, Methods, Multivariate, select all items, load into the box, click OK, click on Multivariate again, Item Reliability, then we have Cronbach Alpha. So when you look at here, you realize that the overall or entire set of scale, Cronbach Alpha is 0.79. So it's good. So it means that even when you look at the item 3, you see it looks well. And from literature, any item with low loading or maybe Cronbach Alpha, and also you don't have an acceptable Cronbach Alpha, let's say maybe your entire scale is less than 0.7 and you have these items, you can decide to delete them to get a good internal consistency. That's the reliability. So close this. So now we are going to perform our confirmatory factor analysis using the structure equation modeling approach. So I'll click on Analyze, Multivariate Methods. You see structure equation modeling. So you just click on it and you have all your items. So I'll just highlight all, populate this box, click OK. So to make it simple for you, when you scroll down, you're going to see something, model shortcut. Just click here, cross-sectional classics, confirmatory factor analysis, click and highlight all. Enter, let's say, mania, scale, click on add, and you have the scale. Then you click on OK. You can now come up and run the analysis. Or better still, let's say, let me delete this first. Reset. So let's say you want to use the normal approach. Just select all items here. Down here, you can type mania scale, click OK, and you have your model. So the next thing you're supposed to do is, so you realize it's different from EMOS, where you have to draw these things by yourself. So you just click on Run and you have your output. But one thing I don't like about using this jump is that I don't know with the current 18 version whether it works. When you come to EMOS, Smart PLS, we have AGFI, we have GFI, we have the NFI. Like we have a lot of fit indices measures you can look at, but here there are few. So that's the only limitation here. However, the most important ones can be found here. So let's look at this. And with here, I noticed that we don't have what we call a modification indices. So you cannot do any modification indices assessment and also correlation of error terms here. I don't know whether there's another approach. I've not come across it yet, but there might be something that is hidden. So we look at the RMSE, which is 0.134, just like what we saw in the exploratory factor analysis. It's greater than 0.08, which is the maximum. So it means that we don't have a good. However, we look at the CFI, and the CFI is what, 0.94 or 0.93. When you convert it to 2 decimal place, you realize that it's 0.94. So we have a good CFI. So we scroll down and we have our estimates. So the first thing you need to look at is the loadings, which is here. So you realize that when you get a loading of 1 and above, it means that by default the software gives you unstandardized beta estimates or factor loadings. So the only thing you need to do is to change them back. But with here, I don't know whether you can change that. Let me see. Okay, show square. No, here, yes. So when you click on show estimates, then click on standardize. These are the loadings you have. Just look at the item 3. You realize that it's still loading very poorly as compared to the one we see in exploratory factor analysis. So, and the recommendation is that you should have a good RMSE below 0.08 or equal to 0.08. All loadings should be okay. So, but we need to look at certain things. We need to look at the convergent validity and the reliability before we can come into conclusion with this, the deletion of the items. And we know that whilst deleting these items, we need a minimum of 3 items or indicators to load on the construct. So if you have only 2 items on the construct, most people will tell you, or most of literature will tell you that it shouldn't be so. So I will just click on here. If I want to see the standardized parameter estimates, I'll just click here and I have the loadings. What I see here reflects on the diagram here, but this is not of interest to me, so I'll just click here. Sorry, then I'll uncheck it, click here. I'll see access measurement model, so I'll click on this and I'm able to see this. So when you look at here down there, you see construct validity, so it's telling you the AVE, and you realize our AVE is 0.4453, meaning 0.44, which is so low, below when you compare it against the 0.5. It means that something is wrong, and it might be due to the indicator 3 we identified. So let's look at the composite. The composite, the omega, that's the McDonald's omega for composite reliability, 0.7 is okay. Reliability is 83, it's okay, but convergent validity is very important. So what we need to do, so even you can even see it here in JMP, you realize that we have a cutoff which is 0.25. This is the line, and this 5. So you look at the first item, it is above 0.5. It means that that's a squared standardized load. The R square is good. So the only thing below is the item 3, the ASRM3. So it means that it's problematic. So we need to look at this trend and we'll determine which item to delete. So we should look at these two. You see that 3 is the lowest, followed by 4. So we compare to see whether deleting item 3 will help improve the AVE, or we need to add item 4, since we are looking at a minimum number of 3 items under each construct or under the particular scale we are talking about. So just close this. We can go back again, even though it was a mistake. Recall again. Let's remove this and let's do mania again. So we do the mania, then we say add. So it means that we don't have the item 3, then we'll come up and run the model again. So we need to go back and look at the AVE again. So we click on structure equation modeling, assessment measurement model. Then you see that, wow, so you see that our AV is now 0.5087, approximately 0.51, which is above the recommended 0.5. So we can decide to say that we'll leave the model this way. But we forgot to look at the parameter estimates, the RMSE, and also certain things. So we can uncheck assessment of measurement model like this. We can uncheck it. RMSE is here 0.197. So let's say we want to, let me see whether we can correlate. Select. We cannot correlate it here, but let's consider looking at the AVE again and see which one we need to delete. So let's say we'll delete item 4 too. So we'll come back again. Let's click on item 4. Let's see whether we can delete it here. Let me press my delete. No, I cannot delete it here. So I need to delete this again and go this way. So I'll rerun the model, mania, scale, add, and run, and look at my RMSE. So you see my RMSE is so poor, and also CFA has reduced significantly. So let's go back to the 4 item and see whether CFA is okay. So we need to go up, press delete, click on this 2, 4, 5, mania. We run our model again. We have very low CFI. Let's look at the unstandardized, show estimates standardized. We have 0.4. So our RMSE is 0.97197. CFI is 0.837. So if it was to be AMOS or Smart PLS, we could decide to look at the modification indices to see how we can correlate error terms to achieve a good fit. We could have even leave the item 3 and see how well the model will change with the modification indices. And these parameters can also be influenced by the sample size we are using, because most of structural equation modeling softwares use maximum likelihood. So to get a good estimate and good model fit, you need to have what we call a minimum sample size of at least 200. But we have what we call the 78 participants. So you see sample size 78, and you see yes checked green. It means that we're using maximum likelihood extraction, or maybe for the analysis, and it's convert in gradient. So this might also be a factor. But if you come back and you look at your measurement model, you realize that we have a good construct validity, or AVE, and we have good composite reliability, and also the construct maximum reliability. So that is how we perform structural equation modeling using JMP Professional.